Okay, so I hope you have your packet out that we started working on in class on Tuesday, where we were trying to sketch the derivative of a function, and it was matching, but we covered up the choices and we made a guess as to what we thought it looked like. So we did problems 1, 2, and 3 together, and so I would like us to do problems 4 and 5 on this video. So here's what problem 4 looks like. And again, I've covered up the choices because I want us to really think about this before we make a guess, because in the next video, there's not going to be choices. And so we really need to get the practice on this. Okay, so if we think about the things that we talked about in class the other day, then we can say, well, we looked for some things that were significant. So take a second to just think about what some of those things were. All right, and then maybe let's mark them down. So one thing that we talked about was, is there a spot where the graph has a horizontal tangent line? Right, so that would happen right here. So the slope at that point is 0 because it has a horizontal tangent line. Right, and then we also talked about where the function is increasing and decreasing so that the slope would be positive or negative. Right, so if we label the graph, then I would say that the slope is negative here because it's decreasing. And here m is greater than 0 because it's increasing. But also, isn't that interesting that while I see like a nice little turn here, this really looks very, very linear, this part. It doesn't even look like it's quadratic or something. It just looks very, very linear. So I would say that the slope looks pretty constant here. And we could say the same thing over here. Even though this is going to be a negative slope that looks constant, it still looks constant. Right? So if I were to sketch that, I would want to put at 0, the slope is 0. Right, again, the value of the function looks like it's 2.5 here, but again, we're graphing the derivative, so we don't care what the value of the function is. We just know that the slope is going to be 0 there. And I would say that here, I don't know, let's see, at 5 it looks like 5, at 10 it looks like 10. I guess that that is a slope of 1. And so if that's 5, then maybe slope is 1. So maybe this is just going to be something like this constantly. And then same thing here. And again, I'm not going to draw this as like this. Remember when we had the absolute value and it was a very sharp turn right here. This does look like it rounds out here, so I'm not going to draw it distinct like that. It probably curves up something like that, because it does look like it is a continuous and differentiable there. So I would guess that it's going to look something like that. Again, let me darken it a little bit in case the glare is too much for you. All right, so then let's look at these different graphs. So for part A, well, that can't be it, because this would indicate that the slope is increasing. Not that the function is increasing, but that the slope is increasing. And that's not what happens. The slope is constant. So it's not going to be that one. All right. Then if we look at B, well, again, it's got 0 at 0, which is good. But again, it looks like the slope is increasing, even though we know it's constant. All right. So I would go with no on that one. Then we look at C. Well, that looks like ours, but this says that the slope for positive x values is negative, which is not what's happening. It's positive, and here it's reversed. So I would say no to that. And then here we go. That is what we guess. That's what it looks like. Sorry, I hope that it's... I can't even tell whether it's in my screen or not. All right, so I hope that you could see these pictures that we're looking at, but it should be D. That is the one that looks like our original graph. Okay. Let's look at number 5, and again, I'm going to cover these up. All right. So if we mark what is important here, I would say that at these 3 spots, at that max, that min, that max, that the slope is 0 at all 3 of these points. They would all have horizontal tangent lines. All right, here the graph is increasing, so m is greater than 0. It's also increasing here. All right, so we've got these 2 spots where m is greater than 0. But then here we've got these 2 spots here where m is less than 0. This is going to be hard to graph. Or not hard to graph, but hard to mark off. So this is the one where it's greater than 0. But then here m is less than 0. And right here, m is less than 0. All right, so if we, again, I drew this, you can draw it on yours too. At -5, it should be 0. At 0, it should be 0. And at +5, it should be 0. Right. And then it should be positive for everything here, right? And again, it's really steep here, so that's a big slope. And then as we get closer and closer to this -5, at the x is -5, it gets closer and closer to 0. So we need a positive, but approaching 0 here. I think we drew one kind of like this, where we said it's positive, but getting closer to 0. All right, here it's got to be negative because it's decreasing, but again it's going from something close to 0. It's got its slope here that's increasing, but then again it decreases as it gets to the bottom. All right, so take a second to think what that might look like, and again feel free to pause and look back. I believe that was problem number 3 that did that. Let me just look at my answer key here. Yeah, problem 3 did something like that. All right, so hopefully you look back and you saw that, oh, that's what we did right there. All right, then it is increasing here, so it's got to be positive, but again, it's going from a slope of 0 to another slope of 0 and positive, so it's going to look something like this. Right here, and the rest of the time it's all decreasing, so the slope is negative. So again, here it's close to 0, but it rapidly drops. Right, so we should expect something like this. Sorry, my pencil's really long and it keeps hitting the leg of the I think I've got the camera on. Pick a shorter pencil. All right, so probably something like that. All right, now if we also pause to think about what type of function this is, it shouldn't be surprising. This is a form of a 4th degree polynomial. All right, so again, all even degree polynomials are going to either both end this direction or they'll end facing down. Sorry, I can't do that. There, end facing down. And so that's what this one is doing. So if that's, and again, the fact that it's got 3 turns here, turns once here, turns another time here, turns another time here. We haven't talked about this yet, but the number of turns in a polynomial is usually 1 less than its highest degree. So here there's 3 turns, so we can expect that this is some sort of x to the 4th. So then it makes sense that our derivative would be a cubic, and that's exactly what this looks like right here. Looks like a cubic with a negative slope. All right, and this also would be a negative x to the 4th because it's pointing down. Again, we'll talk more about that later. Okay, so let's see which one of these it looks like. All right, no, for so many reasons. It's not 0 at 5 and -5, which it should be, so that is wrong. Right, this is 0 at 5 and -5, but it's going the wrong direction. Again, here our slope is positive, right? And so our derivative should be positive, but in part B it's negative, so that's a no. Okay, again, this is not 0 at 5 and -5, again, where it has these 2 maximum values, so that cannot be it. And then we get to D, and that is our graph. Okay, nice job.